Hey folks, another NixOS video here. Today's a good one. Today, we're going to talk about using older working revisions of software when the latest revision from Nix packages doesn't work. Are you ready to have your skull caved in? You holding on to something? Because this is cool. It's easy to forget how cool Nix is as you're using it. This is mind-bending. So, remember the last time you're using Ubuntu or whatever, and you upgrade your shit or put a PPA in or whatever, and something broke. If fucking just something didn't work because this package depended on that package and it busted something else, or what I'm talking about. It might even because the thing that you upgraded was different. It didn't change, but something changed underneath of it, and it just didn't like that, and it stopped working. So Nix doesn't really work like that. A Nix derivation, piece of software, depends on other specific derivations, other pieces of software, obviously, but each derivation has a hash. So when the derivation builds, the other derivation's hashes are used to produce the hash of the thing that depends on those things. And so the rootmost derivation, the tree of derivations has a hash. And when it's put into this, when that derivation is put into the store, it has a hash at the beginning of it. So we can see if we go look at, I'm sure everyone knows this by this point, by this strangeness. We can see all these hashes at the beginning of these things. We can see that there's one for pulse audio, etc. All hashes. But the way that it works means that each derivation, when it's built, doesn't depend on a specific version of software. Grep, I don't know, GCC. Yeah, we have GCC 7 on here, but we have multiple versions of GCC 7. GCC 7.5.0, we have multiple versions of GCC 7.5.0. The reason this is because each derivation doesn't depend on the software version of what it's building. It depends on specific on the inputs that are its dependencies. And so each derivation has a list of its dependencies and their hashes, and then it has its own hash. So if something changes from underneath of GCC and it is rebuilt, the resulting hash will be different than the last time it was built. And thus we have two different versions of exactly the same version of GCC. So it stores all that stuff in all those dependencies with the updated hashes and GCC in the store. I'm sure most of this is review for a lot of people, I suspect. At each build time, even though the software might have the same revision, it's still building the same, downloading the same tarball that represents GCC 7.5 or whatever. The hash of one of its dependencies was different in some specific point in time. And these points in time are captured in changes to Nix packages repository when people make a commit to it. So it's totally possible to reverse engineer exactly which commit happened in the NixOS GitHub repository. So people make changes to it, they push it up to the repository, and the repository changes result. The changes to that repository result in packages with new derivation hashes being built. That's how that works. So, and the only reason, like I said, Nix packages GitHub repository is just a big honking set of how to build software from source, where to download it from, et cetera, et cetera. Now, in the old days, you might have used something like Gentoo, and you would have seen when you rebuilt a Gentoo system, it tried to operate in much the same way, but it would literally go rebuild all the source for you. It would download GCC, it would build GCC, it would download bind, it would build bind. The only reason NixOS doesn't, you don't see that as much in NixOS. You do see NixOS download some things and build them from source, but it's usually only for packages that are not redistributable, like the NVIDIA drivers and so forth. The reason that you don't see it work like old school Gen 2 is because the first thing that Nix does when it tries to go build a derivation, it knows its hash already. So it goes and looks in a cache for a derivation with that hash. And then it looks in the same cache for the derivations upon which that derivation depends with the hashes that are listed as dependencies. So it tries to grab all that stuff, and usually nine times out of 10, it's available in the cache, at least for AMD 64, 64-bit x86 or whatever we want to call it. So the primary mechanism that's used to populate the cache is a build system that's called Hydra. And Hydra lives here. Stand by. And what it does when a change is made to the nixpkgs GitHub repository, and probably other repositories too, the Hydra build system takes notice, and it tries to rebuild the dependencies that were changed as a result of the commits that were pushed to GitHub. If it has to, if it must build new derivations, it does. And if those builds succeed, the derivations that were built by the build system, it's as if the build system is running NixOS rebuild, but it's running NixOS rebuild for every package. Those derivations are jammed into the cache. Now the cache lives over at cache.nixos.org. It doesn't have much of a UI because it's meant to be accessed programmatically, but that's where it is. All right. But throughout time, each time a successful build happens as a result of Hydra noticing the change to GitHub and building a particular derivation, that derivation is made available to the world by virtue of Hydra jamming it in the cache. All right, are you with me so far? Because we're going to get to the mind-bending part. We're getting there. All right. Here's the mind-bending part. If something is ever built successfully as part of a Hydra build resulting from nixpkgs or anywhere else for that matter, chances are you can still use it today on your system. It could have built 5 years ago, but it's probably still in the cache. So if you want to go use an ancient piece of software, you can. And this is useful. This isn't just a parlor trick. Okay, so it's just mind-bending. It's mind-bending. So let's take a look at how this might be useful. All right. We'll go take a look at bind. We see that bind is at version 9.18.3, and this is under I think the 2205 channel. And the thing that we want to take a look at is the build that is for x86-64 Linux. So that's down here under platforms. We'll click on this, we'll be transported over to Hydra. And here are the last builds. Each one of these builds represents at least one derivation in the store. In this case, I think bind, the package, actually has many outputs. So there's actually 1, 2, 3, 4, 5, 6, 7 for each build. But one of those outputs is bind itself. And I'm sure it's too small to read. Let me see if I can make it a little. Yeah. So what it tells us to do, if we want to get exactly that version that's represented by that hash, that derivations hash, the one that was built at 2022 0713 8 in the morning, whatever, we could do exactly what it tells us to do here. Copy this. You can copy it, take it over to our terminal like that, and it would go ahead and install that plus all the dependencies the derivations that particular build of bind depends on. We would get that. It would wind up in our store for whatever that means. It would be executable at that point, as long as we could find it in our store. That's not very impressive because that's the latest build. But what if it was 10 years ago? All right, of course, I don't think NixOS, gonna have enough money to retain infinite copies of builds, but I mean, certainly for a few months, seems totally reasonable, or maybe even a few years, possibly. I don't know. I don't know how long, but back the thing's cached. So let's take a look at this actually working in practice. So I use a video editor named Olive Video Editor, and I want to use it. So I put it in my Nix configuration. Oops, I didn't want to do it. And then this is just this is an alias for rebuilding my. This is an alias for NixOS rebuild. So if I do sua nix like that, the only change I've made to my configuration is to add the Olive editor. I happen to know that's the name of it. I looked it up in the search thing. Yes, I want that editor. Please give me that editor. Olive editor failed to build. So this may have happened to you on occasion, where you put something in your configuration and you come up with an error during the build. Now, one great part of Nix, which is we don't even have to mention because it's just taken for granted, is that our current configuration was left completely untouched. Nothing happened as a result of that. Nothing happened. Nothing that is not idempotent happened. But it still failed. So even though we didn't break our old system, we definitely didn't get what we wanted. So we should go back. We should search for Olive Editor. Okay, there it is. Show more details. x86 64 Linux. Oh look, it's been failing to build for some time now. So one of the links in here is to go see the last successful build. Now this isn't going to work because it's been too long, and Hydra has purged that build from its history. I don't know how long Hydra keeps around builds. I'm not talking about the cache. The cache has not purged it. But Hydra, the build system, has purged information it had about the build run. So I happen to have caught it at a time when it hadn't purged it yet. So I was able to grab this what it told me to do about nixenv here. All right. When we clicked on the binds help thing, it showed us something very similar. This thing. We tried that. So what it's telling me to do is do this, and you will get the last known good build of Olive Editor. So I'll do it. Grabs all these ancient derivations from the cache. I mean, I don't know how old they are. Probably a couple years old. Or maybe a year, something like that. And now, if I want to, I can go and find it. I wonder if it's actually even available. Like if I just search for it, probably is. It's actually not, even though you see that there, that's one I created. So it may, but I can easily find it. I can go ls nix-store grep olive, and it's going to be in here. It's going to be in here. Blah 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 blah. Copy. And I can go nix store, that, bin, Olive Editor. It works. It works. And it works perfectly. Okay, so if your mind isn't smashed by that, I'm not sure what will smash your mind. We passed in to nixenv this store path. Usually what people pass into nixenv is just a package name, so it looks like that. And if I did that right now, it would try to do exactly what I'm telling it to do, but it would do what I had showed you failed the last time around, where I tried to compile Olive and it had some sort of problem. If the Hydra build system can't build it, you probably can't either. Just this way, it's doing almost exactly the same thing as this is effectively what the Hydra build system is trying to do. If it failed, you're probably not going to succeed. So I'm not even going to bother trying. Nixenv operates a little bit differently. Nixenv-I operates a little bit differently when the thing that you pass into it isn't a package name, but starts with /nix/store. It's called a store path. And instead of trying to actually look up the derivation definition in the Nix configuration, in the Nix packages configuration, what it does is it bypasses that and says, hey, I know that this guy wants something from the store. I've built it before. I don't need to build it again. I just need to get it. So, and that's called realizing a derivation. That's the technical term that Nix uses for it. And really, all it means is when you prefix something with /nix/store and then pass in a hash and a package name, well pass in a nix-store path, it bypasses the step where it would have tried to build it, and it just grabs it. That is just fucking mind bending to me that works. It is literally astounding to me that this works, and it is a shame that more people don't know about Nix. That being said, this way of doing this, where we would, where I just installed the Olive editor. So now if I do nixenv and -q, I can see that I have Olive editor installed in there. I'm not a huge fan of imperative installation of packages like this, because the whole point that people, you started to use NixOS in the first place, is because it was declarative and I could repeat my builds. And once you go off into imperative land like that, where once you have a step that you have to type a command and install something, it's no longer declarative anymore. It is dependent on outside steps. So, in my opinion, Nixenv sucks, imperative configuration sucks, and it sucks for all the reasons that you hated your old system and you started using NixOS. So don't use it. Don't bother. Instead, what we can do is we can uninstall it this way. Uninstall Olive editor. All right, it's gone. And we can change our configuration, and we can just put the nix-store path inside of this list that is a list of environment system packages. So like I was telling you before, like nixm-I takes either a package name or store path, the list of things in here can either be package names or store paths. And when it's a store path, it'll do exactly what nixm-I did, which is try to install it. So let's do it. Nix. Don't think it's going to download Olive Editor again, that derivation again, because it already did when we did nixenv-I. But it's there. All right. All right, now is it in our launcher? It is not. Now that is my own, and that will work. So I think once I do that, yeah, man, it's there. So now I don't have to install it imperatively. I don't have to do what the Hydra build system told me to do. I can just jam it in here. I find this endlessly amusing. And it's not like I didn't know that Nix did this. It's just seeing it work in practice and work so well, and be like, yeah, okay, yeah, you have this problem. hey, I'm going to solve it for you. I'm going to solve it for you. So all you have to do is change one line in there, go back in time 3 months, time travel just for that one package, and everything else is definitely going to work. And it is just fantastic. It is super cool. And I hope you are as entertained by that feature as I am.